Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture we are going to implement TD Lambda in code. We are going to take the same approach as the n-step script, where we import most of the stuff from the earlier Q-learning script. One thing to keep in mind as you look through the code is how much simpler it is than the n-step method, even though theoretically it's more complex. If you don't want to try to code this yourself, although I highly recommend you do, the relevant file in the course repo is tdlambda.py in the subfolder Mountain Car. At the top we have all our usual imports. After that we have our definition of the class base model. This is like the SGD regressor we wrote earlier, but I don't want to call it SGD regressor since it's now using eligibility traces. I've renamed some of the arguments in the fit function so that you can see what's what. Predict is the same as usual. Next we have the model class. This is going to be a little more complicated because we have to keep track of the eligibility vectors as well. In the constructor, we initialize a base model for every action and an eligibility vector. The predict function is the same as before. The update function is where all the big changes are. First, remember that part of the eligibility vector update is just gamma times lambda times itself, so we can do that first. The next step is to add the gradient, which we know is just the feature vector itself. The sample action function is also the same as before. Next we have the play1 function. I don't think anything in here should be surprising. It's all stuff we've seen in previous scripts. We have an additional argument lambda which is as expected, but we are still doing Q-learning. Notice how much simpler and shorter this is than the n-step method. We no longer have to keep track of all the rewards, nor do we need to do a catch-up loop to run through the rest of the states after the episode is over. Next we have the main section, which is exactly the same as before. So let's run this and see what we get.